Hello everyone, and welcome to our first lecture on the fundamentals of programming. I'm excited to embark on this journey with you as we explore the fascinating world of coding and problem solving. Let's start with a fundamental question. What is programming? At its core, programming is the art of instructing a computer to perform specific tasks. You, the programmer, write a series of instructions. We call this code, and the computer follows these instructions precisely. But why do we program? The purpose of programming is multifaceted. Firstly, we program to solve problems. Whether it's calculating complex mathematical equations, processing vast amounts of data, or creating interactive websites, programming allows us to leverage the power of computers to tackle tasks that would be time-consuming or impossible for humans to do manually. Secondly, we program to automate repetitive tasks. Think about a task you perform repeatedly on your computer. Now imagine if you could write a program to execute that task for you, saving you hours of time. That's the power of programming. Thirdly, we program to create. From developing mobile apps to designing video games, programming is a tool for bringing ideas to life in the digital world. Now, let's talk about a crucial concept in programming: algorithms. An algorithm is a step-by-step procedure for solving a problem or accomplishing a task. It's like a recipe, but instead of cooking a meal, you're solving a problem. For example, let's say you want to find a specific book in a library. Your algorithm might look like this. 1. Go to the correct section based on the book's genre. 2. Look for the author's last name. 3. Scan the titles until you find the right book. This is a simple algorithm that we, as humans, follow instinctively. In programming, we need to break down problems into these kinds of step-by-step instructions that a computer can understand and execute. This brings us to the importance of problem-solving in programming. As a programmer, you'll often face complex problems that need to be broken down into smaller, manageable parts. This process, called decomposition, is a key skill in programming. Let's consider a more complex example. Imagine you're tasked with creating a program for a bank's ATM. You'd need to break this down into smaller problems. How will the program verify the user's identity? How will it check the account balance? How will it process withdrawals and deposits? How will it update the account balance after transactions? Each of these sub-problems would then need its own algorithm, which you'd implement in code. As we progress through this course, we will explore these concepts in greater depth. You'll learn specific programming languages, their syntax, and the associated tools. However, it's important to remember that at its core, programming is fundamentally about problem solving. The history of programming languages reflects the evolution of computer technology. We have come a long way from the binary machine code of the 1940s to today's high-level languages like Python, Java, and Swift. Each new language has made programming more accessible and powerful, creating new opportunities in software development. Key milestones include the introduction of assembly language in the 1950s, the emergence of high-level languages like Fortran and COBOL in the late 1950s, the influential C language in the 1970s, and the rise of object-oriented languages in the 1980s and 1990s. The Internet boom introduced web-focused languages such as JavaScript, while recent years have seen the development of languages optimized for specific purposes, such as data science and mobile app development. As we begin this programming journey, remember that while tools and languages may evolve, the essential skills of problem-solving and algorithmic thinking remain unchanged. Programming is a powerful way to bring ideas to life in the digital realm, and mastering it unlocks a world of possibilities for creation and innovation. Remember, learning to program is akin to learning a new language, requiring time and practice. Don't be discouraged if things don't make sense right away. Each concept builds upon the last, and before long, you'll be amazed at the problems you can solve and the creations you can bring to life with code. Thank you for your attention today. I look forward to guiding you on this exciting journey into the world of programming and seeing you in the next video.